Okay, so a new topic, inequalities. Inequalities. Wherever you write your notes, inequalities. Inequalities. Mhm. So they are okay greater than. We all know that that's the symbol. Don't confuse them. Less than is this one. Huh? Then we have this keyword here, at most. What does at most mean? If I say at most 5 students, what does that mean?
Doesn't that mean that's the maximum?
At most, it means it's the maximum. Huh? It can't go be. It means 5 or lesser. So at most means less than or equal to. Clear? At most means less than or equal to. Then the word at least means greater than. If I say at least 10, it means 10 or greater. Clear? Greater than, sorry. Simply greater than or equal to. Making sense?
Yeah.
Okay. Question? No question so far. Now, having said this, we want to look at inequality equations, then we look at the graphs. See why it was important to know straight line graphs. Maybe that's the last graphical, then we look at something else. Now, the same way you solve equations, huh? If this was an equation here, how would you solve this from form 3? You group like terms, huh? You move that, so that I have 3n. I move the 5n, and it becomes n minus what? Minus 5n. Huh? Are we agreeing? Is equal to minus 18. Then you move the negative 11, the other side it becomes a plus 11. Then there you get 3 minus 5 is minus 2. You can check from my calculator. So it's minus 2n is equal to minus 8 plus 11. You can check from your calculator. That should be exactly minus 7. Clear? Then you divide
Yes, sir.
both sides by negative 2, like this. Then you get n is equal to 7 over 2. Negative is a positive. That is if it was an equation. Now, this is not an equation. This is an inequality. So, I just so that you see the difference. Now, if this is an inequality, the same concept is the same. I want to move 5n the other side of the inequality, it changes sign, huh? Becomes a minus. The sign is not an equal sign, it's a greater than. Minus 18, I move the negative 11, the other side is a plus 11. You get minus 2n is greater than minus 7. Click. Making sense so far?
Yes, sir.
Then there's a very important thing that I need you to write down here. You can write MB. Then you write whenever we divide by an inequality, by a negative. Whenever we divide by a negative in inequality equations, right? That whenever we divide by a negative in inequality equations, the inequality changes direction. Hmm? That's all the only difference. The inequality changes direction. So it means this changes and becomes a less than. Clear. That's the final answer there. Or 3.5 or 7 over 2. Doesn't matter. Are we together?
So could you please repeat the points? What you said?
Whenever we divide by a negative in inequality equations, whenever we divide by a negative when dealing with the inequality equations, the inequality changes direction. The inequality sign changes direction. Whenever we divide by a negative when dealing with inequality equations, the inequality sign changes direction. Clear?
Yes, sir.
Only that. So you can write that example there. We've worked together. Some people are joining late, or unless it's the network. Sarah, you're there?
Yes, sir.
Someone's network, I think, is playing up. Anyway. So far, so good, huh?
Yes, sir.
I missed all of that, Mr. A, because my phone disconnected.
Yeah, but we are here. We are simply using inequality here, and we said what we simply wrote is whenever we are dividing by a negative, like what we are doing here, whenever we are dividing by a negative when dealing with the inequality sign changes direction. That only applies to inequalities. Huh? That I was showing you the difference. Making sense?
So why do you keep it a fraction? Why don't you put it
It's the
into
same. It's the same thing.
decimal?
In maths, it's just the same thing. Clear? I
Okay.
can leave it like that, or I can even write 3.5. Same answer.
So
Yes, same answer.
So it'd be fine if you put into a
Yes,
decimal.
yes. But what I recommend is
Okay.
if the decimal is giving you a perfect decimal, clear. You don't need to round things,
Yeah.
clear.
Then you put it.
Yes, because fractions always gives you a perfect. Sometimes decimal give you have to end up rounding. That's why sometimes we don't do that. That making sense?
Yeah.
Yes, sir.
Everyone.
So can I write this
Now,
next question as an
next,
example?
yes. So this one you can also even write it as an example in your book. Now, the idea behind is to group like terms. Huh? So, Laura, this 3x has to move this side with x. The 13 has to move the other side with what? With 7. Huh? Okay. So, which means it's x. This is a positive. It's moving the other side of the inequality. Now a negative. Is greater than or equal to 7. We are moving a positive 13. It becomes a negative 13. Clear? Making sense? Then if you are not good with x, because your calculator will never give you x, you think of 1 minus 3, huh? But it's in terms of x. You can do 1 minus 3, it gives you negative 2. So it means your answer is negative 2x here. Clear? First, greater than or equal to. You use your calculator if you're not good with direct numbers. 7 minus 13, you get negative what? Negative 6. Huh? Then what do we divide by both sides? Negative 2. What happens to this sign? Because we're dividing by a negative? Kuda changes direction. So x is now, that's the new direction like this. Because a greater than or equal to is now a less than or equal to. Yeah, this direction changes. That's what it said. Because we're dividing by a negative. Negative divided by a negative is a positive. You can check from a calculator what I've just saying.
So,
Yeah?
so do you always divide by 2?
What do you mean? What do you want to find? Sorry, what do you want to find here? X. You want to find the value of x here. This is form 2 or form 1 means. So if you want to remain with x here, what are you supposed to divide here? By 2. By negative 2, because I want to find x. If I say 5x is equal to 40, how do I find x here? I have to divide by 5 like this. So that I cancel the 5 and I remain with x. That's what I'm doing. I'm just applying simple mathematics. I want to find the value of x. That's why I'm dividing by negative 2. Negative 2 divided by negative 2 gives me 1. Any number divided by itself gives me 1x. That's what I want to find. I want to find x. That's why I'm doing that. They're making, does that apply answer you there? I'm not just plugging two. Huh? I'm actually solving equations. But what I want to find is the unknown. Use positive integers. Okay, list the positive integer that satisfies the equation. So x is less than or equal to what? To 3, yeah? So 3, 2, 1, going like that. We're taking positive integers, huh? So we can't go to 0 and you see this? List positive integers. If we now list minus 1, it's not a positive integer. That's satisfied. But we're saying x is less than or equal to 3. So it starts from 3, 2, 1, 0 going, but they want positive integers. Clear? Whole numbers. Now, can you solve this without the teacher? Find the positive integers. You can't find without solving. You have to solve. Quickly try to solve what I've been doing there. I'll give you a minute.
I'm done, Mr. K.
Done, sir.
We should be done now. Are we all done?
Yes, sir.
So
Yes, sir.
the first thing,
Yes.
t minus 3t, yeah? But this is a positive. I'm moving the other side. Yeah? Is less than 6. Move the negative 6 the other side, the positive 2. This side becomes a minus 2 like this. So from this is a minus 2.
Yes.
Okay? Is greater than, you can check from a calculator, minus what? Minus 8. What I want is
8.
t, yeah? Divide both sides.
Yeah.
Then I get a t, sign changes less than 4. So positive integers are 1, 3, 1, 2, 3. If you listed 4 is wrong, because t has to be less than 4. T has to be less than 4. So we can't include 2.
Wait, Mr. K.
Yes, that's it.
Mr. K.
Yes, your question.
The positive integers, I'm kind of confused.
Positive integers only that satisfy this t is less than positive integers. So your t will take all values less than 4.
Okay.
But we are saying integers, which means we are referring to whole
Okay.
numbers less than what? Less than 4. And the only whole numbers are 1. Clear now. Making sense?
Can't read you properly. Someone's body.
Okay. Hey, someone's volume there. Can you reduce your volume? So we're saying the question of saying positive whole numbers are integers, it means whole numbers less than 4. I mean positive whole numbers. So it starts from 1, 2, 3. So we can't list 4 because it has to be less than 4. So those are the only whole numbers. But in general, we are saying t is less than 4, which means it can be fractions. But the question is talking about integers, which means it's talking about whole numbers. Is that clear now? Now let's solve this here quickly. Solve this inequality. Let's do that. I'll give you 30 seconds. Because it's not difficult. Talent, let's solve that. If we go there, let's solve that.
Oh, we're solving this one, right? Without the teacher.
You are done now?
Yes, Mr. K.
So everyone, the first thing that you should have is n minus 5n less than minus 8. Move the 7, becomes a minus 7. Subtract, you get a minus 4n is less than subtract, you get minus 50, increasing in the negative. Divide by negative 4, because you want to find n, divide by negative 4. So n, the sign changes to greater than 15 over 4. You are happy now?
Yes, Mr. K.
Yes, sir.
Yeah, but let's skip and look at this one here. You can write as a good example here. 21 plus whatever is the So what you do from maths, think if it was an equal, we cross multiply, so that we get 21 plus x is greater than 5 brackets x plus 1. That's the first thing. So 21 plus x, remove brackets, is greater than 5. 5 multiplies everything in the brackets plus 5. Then do the normal thing you've been doing, which is x, bring that the other side, minus 5x is greater than 5 minus 21, because I'm taking a positive 21 the other side. I get minus 4x is greater than, subtract there, what you get, negative, you can check from a calculator, negative 16. Then divide both sides, because we want x by negative 4, by negative 4. So the inequality changes direction, because a greater than becomes a less than 4. Clear? Just want to see. Okay, I'll give you. There's no. Okay, I was looking for something that can confuse you. So let me give you one from top of my head. 1 plus that is less than 4x minus 6 less than 3x plus 8. This is just an example. Okay, clear? So when you have this here, okay, sometimes you can get it, is you can split this into 2 equations. I can have this part here, follow me, and this part. Two separate equations. Huh? So my first equation will be 2x plus 1 is less than 4x minus what? Minus 6. Huh? Then my second equation will be this part here, which is 4x minus 6. You can write the less than 3x plus 8. Then we solve the same way we've been solving. Huh? Clear? So now, so I've split it. That the central equation is forming an equation with that. This is forming an equation with that. Now let's solve what we've been doing. So 2x minus 4x is less than minus 6 minus 1. There we get minus 2x is less than minus 7. Divide both sides by negative 2, negative 2. You get that x changes sign greater than 7 over 2. Clear? First part. Let's do the other part. So 4x, bring the 3x, it becomes a minus 3x less than 8 plus what? Plus 6, huh? You can tell. Huh? And this is what? X less than 14. Can you see that? Making sense? Kuda? So x is greater than this, but is less than this. We can actually combine. Huh? So combine. Or if you leave it like this, you get all the max. Combine, it means 7 over 2 is less than x, x less than 14. Making sense? Making sense?
Yes, yeah.
Okay. Now, just to show you some symbols, I haven't seen that in exams, but you can, because they assume that you know it. If I say x is greater than 5, to represent this on a number line, remember number lines. So I'm saying 0, 1, 2, 3, 4, 5, continuing. Huh? X is greater than 5. I put a circle that is open like this. Then I put an arrow that is showing you that x is greater than what? Greater than 5. Clear? Making sense?
Clear.
If I say x is less than 5, follow me. Same number, almost same number line. Of course, number line can go to any numbers, but I'm looking at the key thing. So circle like this, because I'm not including 5. Then an arrow there showing me that it's less than. It's taking all numbers the other side of 5. Huh? Okay, follow me. Then if I say x is greater than or equal to 5. Now on the number line, I'm sure I guess it's almost similar, but greater than. Now I show something like this, because I'm including 5. Huh? So like this on my number line. The less than is this will be black here. Well, now let's combine this. What if we say 2 is less than, 2 is less than equal to x less than 5. So let's see how we do that in the number line. So 2 there, 5. So we want numbers between 2 and 5, but not including 5. Huh? So this 5 here is like this. But this 2 here, we are including it. So like this. That's what it means. 2 less than or equal to x, x less than or equal to what? X less than 5, which means 2, 3, 4. Huh? Or any other fractions in between. Clear? Making sense? Yeah, very quiet. If I say minus 3 less than x less than 10. Don't worry, you don't have to list any other numbers in between. Huh? So this time I'm not including both of them, huh? But it's numbers between them. Like this. Making sense? So far, so good. Huh?
Kind of, yeah.
Now let's look at something for the next 20 minutes. Something that links to what you've been doing. Okay. I'll skip this for now. And go to number 10 and come back to that question. Now, Hassan stores books in large boxes and small boxes. Huh? Each large box contains how many boxes? 20 what? 20. Each large box is 20. And each small box, so large box, I'm writing down what I'm reading, 20 books each. Then small box, how many books each? 10 books each. Now, he has how many boxes does he have? X large boxes. He has X large boxes and Y small what? Y small boxes. Hmm? Are we getting the question now? He has X large boxes. If he had two boxes, two large boxes, okay. Let's say he had two large boxes. How many books would he have in terms of large books? He had two large boxes. Someone's volume there.
40.
It would be
40.
simply 2 times 40. Yeah? So now, if they are saying he has X boxes, it's 20 times what? The number of boxes times the number of books in each box. So it's 20x. Plus, because we're talking of the total, okay? Plus what? Y times how many? Y 10y. Because I'm saying number of boxes 10. How many small boxes? Y. Yeah? That gives me the total number of boxes. What are they saying? You must have at least. Which sign is at least? Who remembers? At least is greater than or equal to. So the greater than or equal to 200. Making sense? Then we can divide, we can see that from this equation here, we can divide everything by 10. If we divide by 10, 2x. If we divide by 10, you're left with 1y is greater than divide by 10, 20. I said show that. Done. Make sense? Sarah? Yeah, there?
Yes, sir.
Okay. Now look, Hassan must not use more than what? 15 what? Boxes, huh? 15 boxes. So the boxes in general is x plus what? X plus y, yeah? Large and small. But they should not be more than. What does this mean? Which sign is this? Can someone tell me which sign is this? Not more than? Not more than 15. What?
Equal to.
Huh? Is less than or equal to. Huh? It means at most. Huh? So not, so it's less than, correct, less than or equal to 50. That's what you're talking about. That's the inequality there. So the first answer there is x plus y is less than or equal to 50. Making sense now. Now, the next part. The number of small boxes must be less than or equal to what? What are small boxes? Small boxes, if you read here, it's x. Must be less than or equal to the number of large what? Large boxes. Huh? Must be less than or equal to. So what does that mean? The number of small boxes must be less than. Huh? Must be less than. So it's less than or equal to what? To y. Do we agree? The number of small boxes must be less than or equal to the number of large boxes. X is less than or equal to y. Or, if you want the other English, it's y is greater than or equal to x. Same answer. Y is greater y. When I move this is a negative, when I move that is a negative, I divide, the inequality changes and y, because the y, the number of large boxes, is greater than or equal to the small boxes. It's just the same with what they've said. So we now have 3 inequalities. Then, next thing which is new to you is they're going to ask you to draw a graph there. I'm going to list the inequalities. I'm going to do it slowly. So now, what's our first inequality? We have it there. 2x plus y is less than or equal to 20. Now, what I encourage students to do is we ignore the inequality now. Let's change the inequality to equal sign. We'll use the inequality when we're drawing the graph, like this, is equal to 20. Then move it the other side, like what you've been doing with the equations, huh? So that our equation is in the y is equal to mx plus c. That's what I mean. So that this is minus 2x plus 20, like this. Then now, I now use, for example, when x is equal to 0 here. When x is equal to 0, plug in 0 there. Y is equal to 20. When x is equal to 0, you can plug in 0. 0 times negative, anything that multiplied by 0. So y is equal to 20. That's my first coordinate here. I want 2 coordinates only. We are now applying equations. 0, 20 is our first one. Then use any value, for example, 10 here. Let's plug in 10 into the equation. We are saying when x is equal to 10, what is our y value? Let's use the equation. So y is equal to minus 2. You see what we've been doing, like that, plus 20. Use your calculator. What do you get? Use your calculator. What do you get? You get 0. Hi. Well, give me 2 minutes. Sorry. Does that make sense? Did we get 0? from the calculator?
Yes, sir.
So it means our coordinates is when x is equal to 10, y is 0. Say that. When x is equal to 10, y is 0, like this. So now I have the 2 points. Then I check my line is less than or equal to, it's fine. Then I use a ruler like this to join my 2 points and throughout the graph. Oh. So it's the other way. Mhm. Like this. Follow me. Yep. Want to be as accurate as possible, and you have to be very accurate when it comes to graphs. Okay. Yeah. Clear? First line.
Yeah.
But now look at this here. What's the sign? It's a less than or equal to. So if it's a less than or equal to, this is what I want you to master. We don't want values greater than, value above the line. So we shade the unwanted region. Because we want values on the line or less. Huh? Clear? The first part.
Okay.
Okay. Now let's do the other equation. We want to do the 3 equations. The other equation is x plus y is less than or equal to 15. X plus y is less than or equal to 15. So let's think of what I said, x plus y is equal to 15. Move the x the other side, everyone. X is equal to minus x plus. I have to start with the x value first because I want it to be y is equal to mx plus c. Now straight away there, everyone, when x is equal to 0, what is y? 15. It cuts at 15, huh? From, if you remember from the
Yeah.
okay. 0, 15. So when x is equal to 0, 15 there. Then plug any value. You can even plug 4. You can plug 14. It's up to you. So I plug 14 into this. When x is equal to 14, I want to find what y is. I use that equation. Y is equal to minus, what is the x value? 14 plus 15. If you use your calculator, you get 1. So that means 1, like this. Then it's a less than or equal to, so it's a bold line. If it's not, it's simply a less than or whatever, it will be solid. We'll talk about this. Okay. Anyway, we want from this point here. Oh, so it has to go the other. Up. Sorry. I didn't want this. Always making sense. Like this, huh? Then again, if we read the question, we want values less than or equal to. Huh? So we don't want values above the line. Like this. Okay. Then the last inequality is we think of the line y is equal to x, which is easier. The values of x and y are the same. Values of y and x are the same. So it means 2, 2, 4, 4, 6, 6, going like that. 0, 0. We've done that when we're doing transformations. Sometimes try to be as accurate as possible. Slightly missed. Okay, some more, something like this. Now, what do you want? Value is greater than, huh? Look at this. Value is greater than. So we don't want values below the line. Huh? So which region satisfies all the inequality? There. Can you see that? Making sense?
Yes.
Say it, is that making sense?
Yes, sir.
Okay, we'll give you a break. So that's what we'll be doing. The first. So I'll send you some notes that you need to read, but we'll be doing that when you come for after exit, whatever. Clear. We'll start with inequalities the first week, then we finish that. We do review.
Thank you, sir.
Okay.
Thank you, sir.
Yeah. Okay.
Thanks, Mr.
Thank
K.
you, sir.
He might